Here we go. So welcome again tonight to JW2542 tutoring. This is my SAT class, which I've been developing over 10 years. Lesson number 9 tonight, graphing linear and quadratic functions. Just to let you know, this is being offered for free by donation. If you know a little about me, I spent many years as a street performer, surviving on generous tips in New York City and also in Europe, around the United States. And so giving back to the community once again, this course is by donation. You can give what you like. The recommended donation is $50 per lesson. The course does sell for tutoring houses between $1,500 and $2,000 per child. But it's my course, so I can do what I want with it. So I'm offering it free online this year, 22 SAT lessons. And if you have a middle school child, also the SHSAT course, 25 lessons are being shared. So thank you for your donation. You can donate at Venmo at Joshua Wiener 10, that is me. And hopefully this course can be published and perhaps bound as a book or sold to a book company in the future as I continue to bring you original content for these standardized tests. So thank you. Let's get started. The SAT math section's overview. Remember that the SAT, still in its current form, will focus on mostly 9th and 10th grade math, with algebra, geometry, coordinate plane, charts and graphs, probability and statistics, and a few other math topics from Algebra 2. There is some good news for non-math majors. In the upcoming digital SAT will not have Algebra 2 topics. For example, it won't have the law of sines or cosines. It won't have complex numbers like adding, subtracting, multiplying, or dividing with complex numbers. So the math will then be focusing on equations, expressions, and word problems from 9th and 10th grade math only. So that's good news if you're a non-math major. Also, it's going from the current form of 58 questions down to 44 math questions. And as those changes are sent more to teachers and tutors like myself, we will adjust our curriculum to serve you as you get ready for the standardized SAT exam. You can see here that this is one of 28 lessons of my class, the way the SAT currently is. Think of it as a checklist of math lessons or skills that you need for the SAT standardized test. Starts with about 10 algebra lessons and then a set of geometry lessons, including the Pythagorean theorem and SOHCAHTOA and 2- and 3-dimensional geometry, and then ends with a few topics in trigonometry and then probability and statistics. If you notice in the 28 lesson version, this is like a checklist of things you should know, formulas and algorithms, step by step, how to solve problems with these 28 topics. So tonight, in its current form, we're going to do lesson number 9, linear and quadratics. Before we do that, a quick beginner strategy for those getting ready for the SAT. Following this slide, notice that section 3, which is 20 questions, so here up on top, and section 4, which is 38 questions, is organized like many math and science classes in high school and in higher education. The first third of the questions are multiple choice or easy level. Then the second third are mid-level. And the challenge blocks are mostly clustered in the third third of the multiple choice. The dark gray boxes are the gridding questions. And then this pattern is repeated, going from easy, mid to challenge level of difficulty, with a few exceptions, crossover questions. But you can see that the level 1, 2, and 3 questions are mostly at the front of each of these sections. And the more difficult level 4 and 5 questions, as they're ranked, are in the later half of the exam. So knowing this and knowing that it's a standardized time test, a good strategy is to take your 25 minutes in section 3, do the easy and mid-level questions fast and accurate, try and get 8 out of 10 or better. Then skip the challenge level block, do any grid-ins that are easy for you, check the time, Say there's 12 minutes left. Then go back to question 11 or any questions you skipped and complete those questions with the time remaining. This will reduce your test anxiety and make you a more accurate test performer because you're working on the easier and mid-level questions as you go through the exam with accuracy. Similarly, with section 4, a good strategy is to do the first 20 questions fast and accurate, skip the next 10 questions, go to the grid-ins, do any ones that are easy for you, check the time, maybe there's 23 minutes left. Then go back to question 21 and spend the remaining 23 minutes working on those 10 questions that are, you can see at blocks of 3, 4, and 5 level difficulty. With this strategy for test takers at tutoring houses, we found that focusing on these 37 questions, 13 of them in section 3 and 24 in section 4, students are able to perform consistently with an SAT score of 500 to 600 points as they work on their proficiency in language as well as reducing test anxiety. You can see that they perform better if they focus on the easy and mid-level questions as they work on their time management. If you're consistently getting between a 500 and 600 score on SAT math, then maybe you can work straight through it and you have enough time. But just be careful with your time management and make sure that you understand it's a standardized test. So you want to have a pace of each question, ideally in less than 60 seconds. Here's the normal curve. As you know, standardized tests with very large data sets are normalized data. So the SAT math section, SAT is taken by between 1 and 2 million test takers per year. So the mean is calculated as the average of all of the data points and is given a 500 score. Then from statistics class, a standard deviation is calculated from the sum of squares. And that gap is used for 3 standard deviations above, up to an 800 score or perfect score, as well as 3 standard deviations below, which would be the lowest score you can get, a 200 score. So remember that colleges, if you're going to add standardized tests to your portfolio as a junior or senior, as you start to apply to colleges, remember that whatever standardized tests you want to put in, colleges want to see you on the right half of the curve. In fact, you can get 1 or 2 standard deviations above in a section. That's even better. Okay, but they want to make sure that you can perform at a college level for their material. They're going to give you textbooks as well as they'll have lectures and labs that need students who can work at a level of proficiency that's on the right half of the bell curve on these standardized tests. Okay, so like it or not, colleges do have their standards for learning, and if you're going to include standardized tests as a highlight of your college portfolio for college, remember to include tests where your score is above the mean score for that exam. Remember that also it's not just your GPA to get ready for college. You have other things going for you. If maybe you work a job, you have family responsibilities, you work at a store, you are an apprentice for a trade, or a working child, or take care of siblings or relatives. Remember that all these things are of course understood by college recruiters as they look for new young people to join their community to be the next generation of leaders from their college. Tonight we're going to remember that we're still in the SAT lessons, number 9. So you should be familiar with these basic concepts that I've written here. PEMDAS, the order of operations. Linear and quadratic word problems from your work in math. Linear equation formulas such as slope-intercept, which I have here, y equals mx plus b. You should be familiar with techniques like adding or subtracting 2 equations in a system of equations. And that standardized tests have systems of shortcuts to help you get the correct answer and save time in your work for these standardized test questions. Tonight, we're going to be looking at lesson 9, a focus on the coordinate plane and representing linear as well as quadratic functions. Before we get to this, we'll do just like we do at the tutoring house. We start with a warm-up quiz, which are 5 practice questions, 2 easy level, 2 that are ranked mid-level from our hundreds of questions, and 1 challenge level question. Since there are word problems, I'll give you guys actually 12 minutes because there's extra word problems to translate on SAT quiz number 9. So I'm just going to get my timer ready and set it for 12 minutes. If you're following along, you can click on the link here in the blue form, the Google link, and it will open up to a fresh form. Just enter your name and email. And then when you're done after 12 minutes, I'll call time. And then submit your answers and the school computer will auto-grade it for you. These are saved on my Columbia Drive. Being a graduate of Columbia University, I'm streaming from a Zoom room from Columbia, which is a service to me as an alumni. And also since I graduated from math education with a master's degree, I can save all of these files and share them for free if I feel like it. Like here, you can use these links to my Columbia University Drive. So enjoy. Remember, I'll be posting the quizzes, classworks, and homeworks for free this year online from my Columbia School Drive. All right, so I'm going to mute now. And good luck. You now have 12 minutes for SAT quiz number 9. Good luck, and I'll see you in 12 minutes. If you're watching the recording, you can pause the video or play it through, and in 12 minutes, we'll resume with a review of quiz number 9. Okay, good luck. Ladies and gentlemen, please finish the problem that you're working on and make sure you have an answer for all 5 questions. That is time for SAT quiz number 9. You go to the bottom of the form below question 5, you should see a bubble sheet with an array of bubbles for you to answer questions 1 to 4, make your final selections. And then for question number 5, please submit your answer on the line provided. You don't have to use the $sign, and make sure you round your answer to the nearest 10, as instructed. If you click this blue submit button on the bottom of the form, the school computer will auto-grade it for you. And what we'll do now is we will go over the 5 questions, and I'll show you a technique to solve each one in less than 2 minutes. All right, so for question number 1, we have easy level. If 24x minus 6 equals 30, what's the value of 4x plus 5? Well, we have here is we have 24x minus 6 equals 30. So I'll add 6 to both sides. Then 24x equals 36. Dividing by 2 on both sides, we have 12x equals 18. I'll divide by 3. We get 4x equals 6. Then I note that 4x is the first term of the expression that we're trying to find the value of. So then 4x plus 5 has to be 6 plus 5, which is 11. So the correct answer was D, 11, for question 1. Question number 2 reads, excuse me, hold on just a second. I don't want that here. Can this come over here? No. All right, question number 2. A winter flu medicine costs $18 per bottle. Oh, okay. The school principal buys a case of 24 bottles for the entire school population. Each bottle has enough for 40 prescriptions. What is the unit cost for 3 doses of flu medicine? Well, there is some extraneous information here. We do need to know the following. Let's see. It's $18 per bottle, and we have 40 prescriptions in each bottle. The fact that there's the principal's buying 24 bottles, like for 24 different classes, is extra information. We don't really need to know that. So what we have to do is we have to take $18 and we're dividing it into 40 prescriptions. That's the cost, and that's the amount of prescriptions. That's the same as $9 for 20. Well, that's the same as $4.50 for 10 flu doses. Then dividing by 10 is much easier. That's 45 cents is the unit cost for 1 dose. But the question was, what is the unit dose for 3 doses? The unit cost for 3 doses. So you have to multiply that by 3. And we get 5 carry, 12, 13, $1.35. So the correct answer was C for this equation. $1.35 would be the cost for 3 doses of flu medicine. C, $1.35. Question number 3 reads, mid-level. Which of the following is the equation of a circle with center 2, 0, and with point 5, -7 on the circumference? How do I draw this with this tool when I don't have graphing paper? Rhetorical question. All right, here is the circle. That means that if I have a line, see, the center is at 2, 0, like so. That would be like a radius then, right? But there's a point on it if we go 3 units to the right and then up, like so, that would also be a point on the circle. So let me write that in. That point is 5 and the square root of 7. This point in the middle is 2, 0. So then what we have is draw a vertical line. What we have is we have the distance between 2 and 5 means the base of this triangle is 3 units. And then the height, or that white stick there, is between 0 and the square root of 7. So that's the square root of 7. So then we can use the Pythagorean theorem for this triangle that's sitting there. In other words, we have a squared plus b squared equals c squared. For this triangle, C, the hypotenuse C is going to be the radius of the circle. So we have 3 squared, which is 9, plus root 7 squared, which is 7, equals the radius squared. 9 plus 7 is 16, is r squared. See that there? Then we use the general formula, x minus h squared plus y minus k squared equals r squared, which you should know from your studies of graphing circles on the coordinate plane. And we have h equals 2 and k equals 0, because that was the center point, 2, 0. And now we know r squared is 16. We don't have to take the square root because we have to have r squared on the right side. So remember that that's the representation. Notice how, wow, the formula for a circle looks just like the Pythagorean theorem. In the sense that it's 3 squares, but that's going around, if you take in algebra 2, it's going around 360 degrees. This is the locus of all triangles, not just this triangle, but as we go around the circle, if you go around in a carousel or merry-go-round, right, as we go around the circle, that will create a reference triangle trapped in with center at 2, 0. If you'd like to know more about that, please check your algebra 2 lessons. But that was the formula for a circle from algebra 1. All right, let's put those metrics in place, those measurements in place. Here we go. We have x. No, that's not the pen. Go away. Wait, fix that one. No, that one doesn't know. No, of course. Anyway, x minus 2 squared plus y minus 0 is just y squared equals 16. That is the correct formula for this circle that we're interested in for question 3. And looking, is there a match? Wait, is it A, B, C, or D? All right, it can't be C because there's a 25 in the parentheses. And a 7? No, it has to be y squared, but it has to be x minus 2, so it's A or B. There it is, B. The 16 needs to be on the right side. X minus 2 squared is correct. Second element is just y squared, and the r squared is 16. Done. B was correct for question 3. Next one. Question number 4 reads, another mid-level question. The Patas monkey can live up to 20 years on average in the wild in Africa. A scientist is following a herd of Patas monkeys with the ages 18, 21, 16, 14, 11, 16, 17, and 15 years of age of these monkeys. What's the average age of the herd? Monkeys are called herds. I'm going to have to look that up. So we're studying the pack monkey, like some Jane Goodall type story here. I'm going to arrange it from least to greatest, see if there's any pattern. 11, 14, 15, 16. And I want to make sure that I have the right count. So I'm going to put a midline. That's 4 and 4. So 4 more monkeys. 16, 17, 18, and 21. Excellent. So that's the ages from the youngest monkey to the oldest monkey, who's living beyond the expected age of 21 years. So of 20 years. It's already a year older. Okay, and then the average. All right, so what's the average age of the herd that they're tracking? Well, you have to add the numbers and then divide by 8. There are 8 monkeys that we're tracking. But look, 16 and 16, that's the same. That's 32. 15 and 17, those two, the younger one, the older one, that adds up to 32. 18 and 14, amazing, that adds up to 32. Okay. And then 21, 31, 32. So you can add it up any way you want. 32 plus 32 is 64. 32 plus 32 is 64. 64 plus 64. 128 years of life among these herd of monkeys. So, that averages out, since they're all 32s, that would, dividing by 2, that would average out to 16. It has to be 16. Let's confirm that. 128 divided by 8. 1. 8, remainder 4. 8. 6 times 8 is 48. That's it. All right, so the correct answer is A. The average age of the monkeys is 16 years of the monkeys that they're tracking. That's the average age. Make sure you check the STEM question. For question 4. Very good. Question 5. Carol saves $1,000, which is earning 6% quarterly compound interest each year. How much will the savings be worth after 20 years? Compound interest formula. Well, here we have a principal. The final amount, the amount final after T years will be the principal times 1 plus the rate percent raised to the T years. You should know this from a basic math or science class. This is the compound interest formula for simple compound interest. Just compound at the end of each year. So she goes to the bank. She puts in $1,000 at the bank. So the amount, hey, I don't want that. She wants her money to grow. So the amount after 20 years will be, she started with $1,000. That's the principal. Then she locked that in place with a 6% guaranteed from the bank. So that's 1 plus 6%, or 1.06 in decimal. She's going to trust the bank for 20 years. She's going to go away for 20 years, earn other money elsewhere, continue working. She's a hardworking lady. But then at the end of 20 years, that money that she set aside 20 years ago, she'll go back to the bank. She'll like, well, it's been growing the whole time at the rate of 6%. Let's take my calculator and I'm going to do just the exponent. See the multiplier. 1.06 to the 20th power is 3.20713. We'll leave it there to 5 decimal places, 135. 6 decimal places, like a statistics textbook from college. Then, since we're multiplying that by 1,000, we have to move the decimal 3 places to the right. So the final value of Carol's investment will be $3,207.13.5, but there's no hay pennies anymore. So look at how much it grew. It more than tripled after 20 years at 6%. Right? No risk investing, because she brought it to a good bank. Business is business. The bank loans it out. People want to buy a house, a car, send their kids to college. They have other things that they would like to buy. So the bank might lend out at 10 or 20% compounded, and then also get extra fees if they go into default. Like if they can't pay their college loan, then they'll be like, okay, now the interest is 25% or something crazy like that. So then all this debt is growing. So, but look at Carol, smart lady, smart investor, will be worth $3,207. We have to round to the nearest $10. So that is $3,210. 3, 2, 1, 0. Done. Okay, so Carol, the smart investor, set aside $1,000 20 years ago. She returned to the bank, it's worth $3,210. Now you might say, wow, she now can shop. She could buy $1,000 worth of groceries. Now she can buy $3,200 worth of food, but it's 20 years later. So we'll have to see, according to the to consumer interest, if she can buy the same amount of food, for example. Now that she has $3,210. That's a different story. But the money literally did grow. Okay, so think about it. She didn't have to work. The money's safe and growing. Okay, let's stop for now. All right. So that's it for quiz number 9. Next thing we're going to do is we're going to go to the core lesson, which is lesson number 9, graphing linear and quadratic functions. This is the 9th lesson of 22 lessons I'm sharing this year on SAT math topics. Think of it as a checklist. And you can go to my YouTube channel later, and anything that you'd like to review for the SAT, like you can just look through the list of lessons and say, hey, maybe I'd like to do graphing linear and quadratic and review that. Make sure that I can go through the SAT level problems. Here we go. As a quick introduction, the SAT mathematics section will contain several graphing problems. One of the questions are with functions which are also linear or quadratic. Most of the questions, excuse me. A few other functions are also tested, sometimes cubic functions, square root functions, exponential equations, like what we just did with question 5 there in the quiz. Logarithms and exponential growth and decay. That's what I mean, exponential growth and decay. Which was the 1.06%, so 6% growth. And some other investing formulas, aha. This lesson will focus on the graphing problems related to functions with linear and quadratic equations. Well, the first representation you should be familiar with is slope-intercept form for linear equations. Here, this is y equals mx plus b in example 1. And you can see here that we're given an equation y equals 3x plus 1, which means that if we read it from right to left, so to speak, what I'm going to do is I'm going to look at the 1 first and then the 3x term second. All right, so the 1 means that on the vertical line, we're going to start at 1, right? That's the y-intercept. So I'm going to put a marble there, a bubble there first, right? Since the y-intercept is 1, we go on the vertical line and we find 1 unit above the origin. That point is part of the line. It's on the locus of points, 3x plus 1. Then, using the slope ratio, we can space out other points on the line, which I'll do with this blue bubble. This is like little blue marbles. We can go 1 to the right and then up 3, because the slope is 3. Go 1 to the right and up 3, place a dot. We can continue this forever, going off the screen to infinity and beyond, so to speak, exiting the picture frame up towards the stars. We can also do this in reverse. 1 to the left would mean 3 down, as the slope is positive and climbing up. A lot of teachers, and myself included, will show you the staircase method. Here I'll use little bricks that are of the slope ratio 1. Rise over 1 is 3 upon 1. So that's 3 vertical steps for every 1 to the right. And you can see that it's a very steep slope, like stadium steps at a sports event. 3, for example. You can see how you have to lift your leg very high. The riser is 3, and then the step is 1. The riser is 3, and then the step is 1. Okay, so that also, those little 3x1 bricks are representing the slope ratio, 3 to 1, 3 over 1. So if you're familiar with this, this will really help you with your SAT problems. Know your slope-intercept form. If the equation is not in y equals mx plus b form, you can rearrange the terms so that you have the slope and the y-intercept, and then graph it accordingly. The next thing to know is not slope-intercept form, but standard form. Standard form is ax plus by equals c. And this is very useful for a different reason. Here, we'll pretend that we have two different rulers. We have we're the ship's captain, and we have an x-axis ruler and a y-axis ruler, these two blue lines. What we can do is we can set the x component equal to 0. Then we'll find a point that's up and down like the y-intercept we had in the previous problem. Then we can also make the left-right distance 0, make y equal to 0. I'm sorry, the up-down distance is 0. And then we can find a point where the line crosses the x-axis or x-intercept. So when we do that, look at what happens. In other words, we take the formula and plug in 0 for x and solve, and then 0 for y. So for the formula here, if I put in a 0 for x, then this term is 0, and we have 2y equals 6. Dividing by 2, y equals 3. So what that means is, it means that 0, 3 is on the line, because I chose my x to be 0. And that's the point there. Then we can also do the x-intercept. We take the same equation, 3x, but now we make y equal to 0. That term will be a 0. 3x equals 6. Divide by 3 and x equals 2. What does that mean? That means that 2, 0 is also a point on the line. So we can use these points. Again, I'll use a green marble here. 0, 3 is the y-intercept, and 2, 0 is the x-intercept. But wait, 2 points determine a line, right? 2 points determine a unique line. So just connect them, and we're done. We have these two floating points. One's attached to the vertical axis, the y-axis. The other one is the x-intercept attached to the x-axis. Think about, you could slide them in either direction, left or right, or up or down. And that's another way of seeing that any possible line can be represented if we were to slide that point to the left or to the right, or if we were to slide this anchor point up or down, right? That would change the slope ratio. It turns out that the slope ratio is also, you can see it among these lattice points if I shade it in with my shading tool. Remember, now it looks like it has a negative slope. So we go 2 over negative 3. Am I saying that right? Well, wait. 2 to the right, negative 3 upon 2. So down 3, 2 to the right. Down 3 for every 2 to the right. So negative 3 over 2 is the ratio if we were to talk about the slope. Okay, but that brings us to another corner point that is on a lattice point, which means that both the x and y coordinates are integers. Here, I'll place an x here, and I'll go down the line, placing other points that are part of the line. 3x plus 2y equals 6. Right, everyone see what I'm doing here? Those are also points with integer values that are a part of the line. 3x plus 2y equals 6. So there in all its glory are the highlights of working with standard form for linear equations. Ax plus by equals c. Says for several questions on the SAT, it's useful to know how to isolate a variable and change the equation from one form to another in various word problems. Given 3x minus 2y equals 12, what's the equation in slope-intercept form? Aha! Well, this is what I was talking about earlier. What we'll do is we'll write the form out. 3x minus 2y equals 12. And then we want to get y alone. So we'll do negative 2y equals 12 minus 3x. And then I'll multiply by -1. So we get 2y equals, then we have to multiply this by -1 and this as well. So 3x minus 12. Then as a last step, we'll divide every term by 2. And we get y equals 3/2 x minus 6. Y equals 3/2 x minus 6. I don't see it. What? Oh, there's an error in the form. It's got to be rewritten. Very upset. Yeah. Those should be reciprocals. The 3 should be in the numerator and the 2 should be in the denominator. All right, so A is incorrect. This should be 3/2. It says a form error. I'll fix that later. Well, it's good to catch it here for sharing it for free. So in the final edit, you don't want your book to have errors. It's good. I'm giving my own editor. So. All right, I'm happy I found it here. Gosh, all right, I'll fix that and I'll write that in my book notes. All right, that's it for linear equations. And the third one is isolation problems. For quadratic isolation problems, to change from one form to another, there we change from standard form to slope-intercept form. Quadratic equations. When plotting quadratic equations, knowing the location of the vertex and if the parabola opens up or down is obviously paramount. One technique for graphing these is to use a 7-point parabola. We plot the vertex and then 3 points before and after the vertex, which are equally spaced. The natural symmetry of the curve will reveal the 3 points that are mapped to the same dependent values in the points after. That's a mouthful. All right, so standard form we're working with for a parabola. Here we go. So first we find the vertex using the amazing formula. We find our A, B, and C. We do a -b over 2a. All right, so here we have A equals -1, B equals -2. See the formulas up here, and C equals 3. So let me write that down on the right side. Right? So extracting the A, B, and C from here, A is -1, B is -2, and C is 3. Those are our coefficients in standard form. The square term first, linear term, and the constant term last. Okay. We have to use x equals -b upon 2a, which gives us 2 over -2, which is -1, which means that the center line for the parabola, where the vertex lies, is at -1. X is -1. I'll draw a vertical green line. That's where the vertex is. So we need to take this formula and plug in x equals -1 to find the vertex. When we do that, we get, I'll erase these drawings. Oops, maybe I'll just put a black card over it, it's faster. Now we can plug in and we get, because we know the vertex is at -1. We have, well, plug in -1. Y equals, okay, -1 squared is 1, but we're making it negative, so -1. -2 times -1 is +2 plus 3. So we get -1 plus 5, or 4. So that means that the point -1, 4 is on the parabola. There it is. That's the vertex. Then it's easier to plug in 0, 1, and 2 because of the equation. The equation is y equals -x squared minus 2x plus 3. So if you plug in 0 into the equation for x, then y will be, well, here it'll be 0 plus 3. Has to be 3. If we plug in 1, it'll be -1 minus 2 plus 3. So it'll be 0. If we plug in 2, it'll be -4. Minus 4 is -8. Plus 3 is -5. So we have these points. You can see here, 0, 3, 1, 0, and 2, -5. Those are here on the graph, on the right branch of the parabola. The 7-point parabola says, well, now we have the vertex, and we have the points that are on the right side. Okay, I'm going to highlight them in blue so you can really see this. 0, 3, 1, 0, and -2, 5. That's not blue. 0, 3, 1, 0, and 2, -5. However, if we go in the opposite direction, instead of increasing x by 1, what if we choose to go the other direction with x and look at -2, -3, and -4? Well, we should get the same values because parabolas are symmetric. There, if you fold the parabola onto itself at the line x equals -1, it should be symmetric. But let's prove it mathematically. It's worth doing because when we're reviewing this idea, yeah, it'll be that'll give us the other 3 points to the left of the vertex. So here we go. So now we'll choose our x value to be -4, -3, -2. Then y will be using this formula. We have -16 plus 8 plus 3. For the next one, we have -9 plus 6 plus 3. Then we have -4 plus 4 plus 3. Well, -16 plus 11 is -5. -9 plus 9 is 0. These cancel. We get 3. So lo and behold, we have the same 3 numbers in reverse order as we go away from the vertex. Check it out. If I highlight it in light blue again, these values here are at the same 1 unit away from the vertex. The distance from the center line is 2 units. We have the same y value. And if we step away 3 units from the axis of symmetry, we also have the same values. So we have this sort of symbol here in the middle, like a St. Andrew's cross, so to speak. We have, or this repeating, this sort of beehive shape. Each of these horizontal stripes shows the symmetry. It's the same, they're equidistant from the symmetry line, the center line, which shows that the shape is symmetric. So a 7-point parabola is very good for mathematicians. You can catch your errors. If you don't have the same 3 values, then you did something wrong mathematically when you computed the coordinates for your parabola. So I definitely recommend you knowing the 7-point parabola. Find the vertex point, plot 3 points to the right of the vertex, and then 3 points with the same step to the left of the vertex, just -1, then go skipping by 1s, -2, -3, -4. Okay. All right, so that is a good example for plotting quadratics quickly with the 7-point parabola. Next, it says, although most of the SAT questions are commonly in standard form, over the past few years, there's an increase in the presence of vertex form of the parabola. A good SAT practice for the exam is to work with a few problems in vertex form, general form y equals a times x minus h plus k, which has a vertex point on the map of hk. So here we go. I'll highlight with bubbles here, with these little marbles here. H and K are here in the formula. That's the turning point of the parabola. Note that for this parabola, x plus 3 means that we have to go to minus 3, right? Because it's the opposite sign. But then since it's plus k and is a plus 1, we need to go 1 unit up. So we wind up in quadrant 2. I'll say it one more time. What I'm doing is I'm finding the exact coordinate of the vertex. X has to be at -3, according to the formula. That's our H, and our K is at +1. So the crosshairs of these two raspberry lines, that's the exact location of the vertex given our H and K. So that's the great thing about vertex form, is you immediately see from the formula itself where the vertex is. Then you can space out the points, plotting from there to the left or to the right. Okay, so then we could plot the points plugging in -2, -1, 0, for example. And then on the right side and on the left side, -4, -5, -6 for x. Okay, and then point the 7-point parabola. I will actually highlight them with little star points here. Since we know it's a parabola, we go 1 to the right and 1 up. We go 1 to the right and 3 up. 1, 2, 3. And we go 1 to the right and up 5. If you don't know what I'm talking about, you can review the idea of growth of a 1x squared parabola, right? So it goes up by the odd numbers, +1, then +3. So 4 units, then +5. So there's our, since a is 1, right? So we had 1 times x plus 3 squared plus 1. So here is our 7-point parabola based on vertex form for the said parabola. All right, if this is confusing, if you haven't done the technique of completing the squares, or if you're with your teacher and you'd prefer to use standard form, then you would have to take this isolated form, y equals x minus h squared plus k. And what will we do? Well, we take the form and then rewrite the terms. Just use FOIL out the square and rearrange terms, and we'll get x squared plus 6x plus 10, for example. And that should work out if we, let's see, the axis symmetry is -b, -6 over 2 times 1. So it's at -3. We have the right center line. And also, look, we have the right y-intercept. If x is 0, we're at 0, 10, right? So that's correct. All right, so you can use standard form if it's easier for you, but it'll take about 30 seconds to, multiply out the square and then group like terms. So that's in degree order. Y equals x plus 3 squared plus 1 is equivalent to y equals x squared plus 6x plus 10. Okay, it's time now that you've seen a review of the linear and quadratic representations on the graph that are most common. What I say, you have slope-intercept form or standard form. Then you have word problems that are isolations or rewriting the equation into an equivalent form. And then for quadratics, use the 7-point parabola or vertex form. That's it for this exam. What we'll do now is we'll do a classwork. And because we only have 90 minutes tonight, the tradition is to do 20 minutes with just half of the lesson. So I have 25 questions for you. But since it's an odd lesson, number 9, sorry, let me fix the slide here. It'd be odd questions only. Okay, so you only have to try 13 of the questions, just odd questions. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and 25 only. So that after 20 minutes, we can review one easy 1-minute challenge level problem, and then you can enjoy the rest of your evening. All right, so please begin classwork number 9. You'll have 20 minutes. I'll set my timer. And then we'll go over one easy minute challenge level problem and end tonight's class. Please click on the Google form link. Again, I'm leaving these active for free on my Columbia University Drive. for SAT classwork number 9, graphing linear and quadratic functions. Enjoy and good luck as you prepare with lesson 9 for your SAT. Okay, just one more minute on tonight's classwork. One more minute. And I put the answers up on the board for the 25 questions. Remember, you should be trying odd questions only. Easy, mid, and challenge level, as well as the grid in, as written on the worksheet. One more minute. All right, so here we go with our review of classwork number 9. I will pick one easy, one mid, and challenge level odd numbered problem tonight. So let's scroll back, and I think I have them set in the carousel here. Pardon me. Let's see. Question 1. Tick marks are equally spaced on the number line above. Which of the lettered points has a coordinate equal to negative a half squared? Okay, so just looking at the horizontal line, like an x-axis here, it's a number ribbon. What we have to do is negative a half squared. So negative a half times negative a half. Negative times a negative is a positive. A half times a half is a quarter. It says they're evenly spaced. So this is 1 then, right? Looking for a quarter. So that means 4 boxes is 1. Everyone see me drawing here? So that means that the quarter will be, where's the line? A quarter will be point D. D was correct for question number 1. D was correct, not E, not B. C, choice C was correct, and that's point D. Blah. All right, any questions on question number 1? All right, let's scroll ahead. Anything else interesting here? Non-linear. Oh, perpendicular. I should know that. So negative reciprocal 7. 7's interesting. 9. 11 is tricky. It's easy with a graphing tool. Check it out. So like an architect or engineer, we'll space it out. I said that so the opposite corners. All right. Let's see. 5, 7. 5 is going to span out to -2. And it's going to go from 7 and drop down to 0. All right, so let's write that out. So this corner is 5, 7. This corner is -2, 0. That's our A and C. So to get from -5 and all go all the way down to -2, that's 7 units actually. And then if we go from the y value of 7 down to the y value of 0, that's also 7. So this is actually a square. Oh, they said it's a square. So it's 7 by 7. That makes sense. So then this is an area of 49. The correct answer is C. See, easy with a graphing tool, but no graph paper was provided. There it is. Okay, any questions on number 3, spanning out from the corner at 5, 7, going down using this coordinate. In fact, if you need to write it down, this would be -2, 7, right? This corner, and this corner technically is 5, 0. Right, that would be our square. Okay. Next question. Let's go to a challenge level problem, unless anyone in chat has a recommendation. Doing one sample of each. You can always email me at JSMW2542 @gmail.com if you have any question on any of the questions here on the worksheet. Too easy. 21, easy. That's not easy. Challenge? Nah, I don't like that one. That one was 10. 19, 17, 15. 15. But that's not. That's mid-level. But it is the challenge. I think it's challenge level problem. Let's see why. Okay. This should be been in challenge if you ask me. All right, first of all, we're starting with a lattice points. Lattice point has coordinates x, y that are both integers. How many lattice points are contained in x squared plus y squared is less than or equal to 6? That is the circle centered at the origin with a radius of the square root of 6. All right, interesting problem. But if you're in pre-calculus, you want to do problems like this. So this is the real deal. This is real math. All right, so here I'll center a circle like that, right? And then what I'm going to do is I'm going to put some axes up, even though they're not necessary. It's just going to make it easier to follow what's going on here. So here's my x-axis, and then here's my y-axis. This is just a quick sketch. All right, so remember that the radius is the square is we have x squared plus y squared equals r squared from our circle problem earlier. That's the general form. Let's start there. So for a circle, x squared plus y squared equals r squared means that the right side 6 is r squared. So the radius is literally the square root of 6. So the radius of the circle is not 6. So if you did that, then there'd be too many points that are contained therein. Here's the deal. Okay, we can only pick lattice points that are less than the square root of 6, like 1 or 2, or the square root of 5 is about 2.3. So the square root of 6 would be about 2.5. 2.5 times 2.5 is, I know, is 6.25. So it's a little less than 2.5. You can see here. So what I'm trying to say here is that we have 1, 0 would work and 2, 0 would work. And let's do the math on those points. Okay. So this point is less than the boundary. This is the radius is the square root of 6. So we want to have lattice points that are inside. Like, let's say we're Johnny Appleseed and we're going to plot some apple trees. And we're going to only plot them every 1 unit of measurement, whether that's a unit could be 30 meters or something, right? But then spacing by every 30 meters, so 1 and 2. But then if we go another 30 meters, we'd be outside, whatever the unit rate is. We can't go to 3 because that would place the apple seed outside of our apple farm, which is a circle. So I say that, let's do the math on the point 2, 0. So for example, if we have xy equals 2, 0, then we have 2 squared is 4 plus 0 is less than 6, less than or equal to 6, which is true. However, the point here, which is 3, 0, is false for the inequality, because when we square 3, we have 9 units plus 0 is less than or equal to 6 is false. So this is inside the circle. These ones are inside the circle, but that one's outside. Make sense? All right, so just as you plot the lattice points, just think of what the squares would be like. 1, 1, that'd be 1 plus 1. 2 is less than 6. 2 is 4 plus 1 is 5. That will be less than 6. Okay, so that means that certainly 0, 1, right? 0 plus 1, that'll be inside the circle. 0, 2, because that'll be 0 plus 4, and 4 is less than 6. Okay, going to the negative. -1 and -2, -1 and -2 along the axes. Because the 2's will just have a value of 4 plus 0 or 0 plus 4, right? Then I can do 1, -1. That's 1 plus 1. That's 2 is less than 6. So let me put these 4 points. Similarly, I can do -2, 1, because that will be a sum of 5. Or I could do 2, -1, because that'll be 4 plus 1 is 5 is less than 6. So here for the 0 level, I'm going from -2 to 2. But also from the 1 level, I'm going from -2 to 2. And down here at -1, going from -2 to 2. Just to give you an example of why this works, here's the point here, -2, -1. But when we use the formula, -2 squared is 4, 1 squared is 1, which certainly is less than or equal to 6. 5 is less than 6, okay? So that point is true as well. It's inside the circle. So far, we have 15 lattice points. Am I making sense? These 15, like apples, could be planted in an array so they could grow space like that. However, we also have the points, it looks like we have a few more. So 0, 2 works, but also 1, 2 will be inside the circle. That's just according to lattice points, there's 1s and 2s, which we know add up to 5. 1, -2 will be 1 plus 4 is 5 when we square them. -1, -2 will be inside the circle, and -1, 2 will be inside the circle. So if I draw this yellow cross here for these apple trees, here I'm drawing it with the shading tool, you can see that these are the only legitimate lattice points. You see how I made like the 2 rectangles? Those are all of them, but don't double count, right? So what I would do is I would count this 3 by 5, that's 15 plotted lattice points. Then these 3 up above, 16, 17, 18, 19, 20, 21, and you get the correct count for the possible lattice points contained in the circle. There are 21 lattice points using all 4 quadrants, right? That are less than the square root of the boundary. The radius is the square root of 6. So that was question 15. All right, I think that was a brilliant question that I wrote personally as a variation on other lattice point questions. Okay, all right. Well done, Josh. I'm proud of you. All right, so boys and girls, I hope that my problems, not all of these are original, but I hope that my problem set is useful to you as you get ready for your SAT exam. And as I work toward creating 100% original material for my SAT class, I'm sharing 22 lessons so far this year. Let's see. I don't know why this black window is on here. Who can see what you're sharing? Recording is on. Well, thank you to the Twitch community and YouTube for watching this recording. It's time to wrap things up for tonight. This is a 90-minute share. No one showed up again tonight for the live class, but thank you for watching the recording. So far, 3 students have showed up for the live class, so I'm looking for that 4th student. Maybe I'll mail those students with the lesson form, see if they're interested in coming back for an free SAT class. What can I say? Thank you for joining me tonight. We're watching this recording. My name is Josh Wiener, and let's wrap up. I'm going to share with you okay, this closing screen. If you'd like to know more about me, you can check me out at JW Test Prep and Tutor, which is my Wix website, JW2542wixsite.com. There you can find parent praise for my over 15 years of working with thousands of students. I've helped them prepare as a math specialist for the SHSAT, TAKS, the cooperative exam, high school placement test, the PSAT, SAT, ACT, AP exams in math, statistics and calculus, as well as physics, as well as the graduate record exam. Also, college students have been accepted into medical schools, business schools, nursing schools of their choice. High school students have received scholarships for a quarter, half, or full scholarship to Catholic schools, as well as students with acceptance letters to New York City gifted and talented high schools. So it's an honor to be a tutor, to be a part of that process of helping your child to succeed by getting them organized and ready and confident for their standardized tests. Okay, that's really been my job here as a math educator for the last 15 years. So helping with time management, helping with confidence, and budgeting your time correctly. Using a checklist sort of skills is a really good strategy to help get your child or yourself organized for standardized tests. Or you can see parent praise, and you can see other notes from educators on my work on this website. You can hire me calling the number above, or by emailing me at jsmw2542@gmail.com, or just email to me on the Wix website. Here are the lesson links for tonight. Lesson 9, the quiz, classwork, and homework problem sets. Each lesson has 25 practice questions. And again, I share the classwork key here tonight. Last thing, question 1 was B, 2 was D, 3 was B, 4 was C, 5 was C, 6 was C, 7 was B, 8 was D, 9 was A, 10 was A, 11 was A, 12 was D, 13 B, 14 B, 15 C, 16 B, 17 D, 18 D, 19 A, 20 was D, 21, 21.4, 25.4, 22 was negative 4/3. Is that right? I'm gonna check 22. I know about 22 now. Come on, what's 22? That's not right. No, 20, that was 8. Why does it say that? Oh, I gotta refresh. This is wrong. Wait a minute. It should be 8. Refresh this page. That's not this answer key. Unbelievable. I'm sorry, this is my course. Yeah, there we go. Going back to the beginning. Last thing for tonight. Classwork 9, solutions, 25 problems. Forgive me. 1 was C, 2 was C, 3 was D, 4 was A, 5 was D. 6 was B, 7 was C, 8 was C, 9 was A, 10 was C, 11 was C, 12 was C, 13 was C, 14 was A, 15 was D, 16 was B, 17 C, 18 D, 19 A, 20 was C, 21 was 45, 22 was 8, 23 was -3, 24 was a half, and 25 was 10. That's it for lesson 9. If you would like to support the development of this course, further development and publication of the course, please, any generous donations to Venmo, Josh Wiener 10, are appreciated as I continue to sit here, boiling my tea and rewriting this SAT class for your use and preparation. Thank you for your support of me as an educator over the years. Again, please check out my website and enjoy. If you like, just send me a friendly email. I can send you the whole set of lessons for my SAT class as you get ready for that standardized test. Happy studying, and thanks for spending time with me. Take care, and bye-bye from New York City. If you'd like, join me on the next class on November 14th, live at 7 o'clock. And thanks, and bye-bye. See you around. Happy studying. Bye. Take care.